Alright, in this lecture we're going to cover implicit differentiation. So when do you want to use it, and why do we even need it? So if I were to ask you to find the derivative of y with respect to x, given that y equals 5x squared plus 3, you could easily just use the power rule. The same applies to y squared plus 5x squared plus 3. You could easily just square both sides, right? And then you could use the power rule. But if I were to ask you to find the derivative of y, given that y squared plus y equals 5x squared plus 3, you'd have to use this new technique that we're going to learn called implicit differentiation, right? Because you can't just take the derivative of y with respect to x if you have y squared plus y. So we're going to actually cover in an example how to use it. So find dy dx given that y squared plus y equals 5x squared plus 3. So what you actually want to do is just treat the terms with y as if though there were x's, but write dy dx next to the outcome of the new term. So y squared turns to 2y, and then you have to write dy dx next to it, right? And all we're doing here is just using the power rule, right? We're going to pretend that that this was an x, right? And the new thing that you have to do is just write dy dx next to it. So y turns to 1 using the power rule, right? But you have to write dy dx next to it since it's a term with y. And 5x squared turns to 10x normally, just using the power rule. And 3 turns to 0. That rule only applies to terms with y in them. So rewrite the problem after differentiating, right? So y squared turns to 2y dy dx. Y turns to 1 dy dx. And then 5x squared turns to 10x. You want to factor out dy dx from the left side, right? And that leaves you with dy dx times 2y plus 1 equals 10x. And you just want to solve for dy dx. You just divide both sides by 2y plus 1. And that gives you your final answer. We're going to go through another example just to clarify it. Find the derivative of 5x squared plus 3xy equals 5y. So we're going to find the derivative of each term first. So the derivative of 5x squared is 10x, right? Just normal power rule. And the derivative of 3xy, you're going to use the product rule and implicit differentiation, right? X is going to be treated as u, and then y is going to be treated as v. And 3 is just a constant. So first we're going to take the derivative of u, in this case is x. So x just turns to 1, right, using the power rule. And y just turns to 1 as well, using the power rule as well. And this is implicit differentiation, so we have to write dy dx next to it. And the derivative of 5y is just 5, using the power rule. And you have to write dy dx next to it. And you rewrite the problem after differentiating each term. Get dy dx on one side. And then you factor out dy dx. And then you just divide both sides by 5 minus 3x. That gives you your final answer. And this is actually a pretty simple concept, so you might want to do a couple more practice problems just to solidify your understanding. And that's it.